Number 37 from our anti-differentiation multiple choice says the integral of the inverse tangent of y over 1 plus y squared dy. So this one is a u substitution one. So what do we want our u to be? Anybody have a good idea there? Yeah, if we let u be the inverse tangent of y, then du is the derivative of inverse tangent. And what's the derivative of inverse tangent of y? One over 1 plus y squared dy. So we've got the 1 over 1 plus y squared dy. That's our du. And then we've got inverse tangent u, which is just u. So this just becomes an integral of u du. U squared over 2 plus a constant, or the inverse tangent of y squared over 2 plus a constant. Good or no? Yeah, wonderful. Other questions? $50, yeah, we can do 50. All right. Number 50, we got e to the x over 1 plus e to the 2x. All right. Anybody have any good thoughts on what to do with that one? What u substitution do you want to use? You want to use e to the x? All right, if we let u equal e to the x, this is a thought by Karina, letting u equal e to the x. That's my dx there. I don't know. Is it good or is it bad? Yeah. You think we should do 1 plus e to the 2x? All right, let's write them both down. This is Austin's idea. Let's write that one down and see which one of these things works better. And then if neither of them work, we'll have to figure out something else to do. Right, so if we let u equal e to the x, what is du? E to the x dx. Yeah? Yeah. Okay, so that, I don't know, does that seem good or no? What about over here with 1 plus e to the 2x? What do we have for du? If we tried to do this one. Just out of curiosity. One of these is going to work out. So.
2e to the 2x.
2e to the 2x dx. All right. So if we look at this one, the du is e to the x dx. Do I have e to the x dx in here? I do, right? So that's my du. And then I have du over this, which we'll think about in a second. If I tried to do this one, du is 2e to the 2x, right? Do I have a 2e to the 2x over there? No. I could get the 2 easily enough if I wanted to, right? By putting a 2 and a 1/2. But I still don't have the e to the 2x in the numerator. I just have e to the x. So I think this way is going to work out better for us, but we've still got an issue here. This ends up being du over 1 plus e to the 2x. Well, this is a good idea, but it didn't end up working out. This is going to work. What is e to the 2x? No, that'd be e to the 2 plus x. E to the 2x is equal to e to the x squared, isn't it? You guys would agree with that? So I could rewrite 1 plus e to the 2x as 1 plus e to the x squared, and e to the x is u, so this could become du, integral of du over 1 plus u squared. And what's the integral of du over 1 plus u squared? inverse tangent of u plus a constant, which gives us inverse tangent of e to the x plus our constant, which looks like it is choice A. So you got to be a little creative with your u substitution and rewrite some stuff. Everybody good with that one at home? And here? Good? Yeah. All right, we got number 14. Number 14. All right. dy over root 4 minus y squared. All right, so if you ever see one of these, this sort of looks like the inverse sine one, doesn't it? Right? Inverse sine is 1 over square root of 1 minus y squared or 1 minus x squared or whatever. But we have a 4 out here. What you're always going to want to do is you're going to want to factor that 4 out. So I know there's no other, you can, what do you get if you factor a 4 out of y squared? Well, you end up with what? What does that y squared need to turn into? What? Well, if I take a y squared or if I take a 4 out of y squared, what does that become? 4 times something has to be y squared. What is that going to be? Y squared over 4, right? So this is going to be our first step anytime we see something like that. Now, the square root of something times something else just means the square root of the first thing times the square root of the second thing. You can separate them into different square roots. So what's the square root of 4 become? 2. So I have a 2 in the denominator. So I could pull that 2 that's in the denominator out in front and make this 1/2 the integral of dy over the square root of 1 minus y squared over 4. Now, what's another way that we could write y squared over 4? Because wouldn't it be cool if this was du over square root of 1 minus u squared? That'd be nice, wouldn't it be? Because that'd be the inverse sine of u, right? So how could I rewrite y squared over 4 so that it's u squared? Yeah, we're going to go with y over 2 squared. Everybody good with that? So then I can make the u substitution that u is equal to y over 2. And du, well, if this is 1/2 y, the derivative of 1/2 y is just 1/2. So 1/2 dy. Everybody good with that? Do I have a 1/2 dy? I have the 1/2 outside, but that 1/2 outside could be pulled inside, right? And so the 1/2 dy will just become du, and we'll have square root of 1 minus u squared, which is just what we were hoping to get. We now get inverse sine of u plus our constant, or inverse sine y over 2 plus our constant. Any questions on that one? At home, are you all good with that one?
Yeah.
Wonderful. All right. 33. Yeah, 33 was the next one. So 33 says an integral of sine 2x dx over square root of 1 plus cosine squared x. Any thoughts on how we might deal with this one? We're going to need a u substitution. What should we let u equal? All right, if we let u equal cosine x, this is Karina's idea. U is cosine x, du is negative sine x dx. Do I have a negative sine x dx there? No. I could turn sine 2x into 2 sine x cosine x. And then I'd have a sine x. I could put a negative in, but then I'd have a 2 cosine x up there, which would become 2u over square root of 1 plus u squared. That's going to be a little bit of a pain. Yeah, I think we could do it. It would work out, but there's going to be an easier way to do this one. It is not like the inverse sine one, actually. So that substitution would work, but it gets pretty complicated. Well, pretty complicated. It gets moderately complicated. The easier way to do this would be to let u equal 1 plus cosine squared x, because that's just going to give me root u in the denominator. And what's the derivative of 1 plus cosine squared x? Well, the 1 goes away. The derivative of cosine squared becomes 2 cosine times the derivative of cosine. So that'd be negative 2 sine x cosine x dx. That'd be the derivative of cosine squared x. Yep. And what do we know about negative 2 sine x cosine x? What is that the same as? Yeah, it's a negative sine 2x dx. So we can just put in a negative, and we have the opposite of the integral of du over root u. And what's the integral of root u, or 1 over root u? Or that's negative u to the negative 1/2, right? So we'll go up to positive 1/2, divide by half. So that's going to become the negative stays 2 root u plus a constant. Or negative 2 root 1 plus cosine squared x plus the constant, which looks like it's choice A. Yeah, look at that, choice A. Fun. Any questions there on that one? Everyone's good? You've all worked diligently through this, right? This packet of multiple choice. Yeah, oh, good. Other questions from the multiple choice? 52. Sure. Integral of natural log root x over, what was it, over x. All right. Everybody good there? Yeah. So what are we going to do with this one? Any thoughts? Anybody just see a nice, easy way to integrate it? I don't see a nice, easy way to integrate. We're probably going to need to do a u substitution. Anybody have a suggestion on the u substitution? Do you guys know how to integrate natural log? The answer is no, we didn't learn how to integrate natural log, right? So that's going to be an issue, right? Having a natural log there. So maybe we want to try to substitute out that natural log. See what we can do with that. Maybe, I don't know, maybe that's going to work. Should we try that? If we let u equal natural log of root x, what would du be? Be the derivative of natural log of root x, right? That's using the chain rule. Within the chain rule, that's natural log of a function, so it should be 1 over that function, and then times the derivative of that function. What's the derivative of root x? 1 over 2 root x dx. Well, what is that if you simplify it? That's 1 over 2x dx. Do I have 1 over 2x? No, but I have 1 over x, don't I? So I could just put a 2 down there. If I put a 2 in the denominator, I need to multiply by 2 also. Everyone agree with that? And that should give me 2 times the integral natural log root x was u And then 1 over 2x dx was du. So just 2 integral u du, which should be 2 times u squared over 2 plus your constant, or just u squared plus your constant. So natural log squared of root x plus your constant, which looks like that's choice. That doesn't look like any of the choices, does it? Why doesn't that look like any of the choices? Did we make a mistake? 1/2 2 u squared over 2. Oh, no. Oh, I see why. It's probably choice E. Does it say it's choice E? Yeah, it says choice E. Yeah, that's annoying. If they're going to make you do this extra algebra work. So this is natural log of root x squared. So that's natural log of root x times natural log of root x, which natural log of root x is 1/2 natural log x if you make that x to the 1/2 and pull the power out. Sorry, it took me a second there to look at that. And so that just becomes 1/4 of the natural log of x times the natural log of x. So 1/4 natural log squared of x plus your constant, which is choice E. Good or no? That's a pain that they would have done that. I would not expect you to have to. I mean, if that was on the AP test, I would expect that answer to show up in the multiple choice, not 1/4 natural log squared of x. But it's still good to know how to rearrange it. So if you see something like a natural log within an integral on the AP test, since you do not know how to take the integral of natural log, you're going to need to find a way to substitute out all of that natural log piece. Right? It's easy to integrate natural log, but you have to know how to do integration by parts, which is calc 2, not calc 1. Any questions on that one? Everybody good there? Other questions? 64. Sure. Let's see here. 64. An integral of 2x plus 1 over 4 plus x squared dx. All right. Any thoughts on this one? This one is a challenge problem, it says. Exciting.
Divide the numerator with the denominator, or separate it, I mean.
All right. Yeah. So we're going to want to separate this into 2 different integrals. That is exactly correct. So in order to separate this into 2 different integrals, we're going to take the 2x and divide it by 4 plus x squared. And we're going to take the 1 and divide it by 4 plus x squared dx. And then we're going to deal with both those integrals separately. So for the first integral, what are we going to do to solve that one?
U equals x squared plus 4.
Perfect. U is 4 plus x squared. Du is 2x dx. That first integral just becomes du over u. And then what about this second one? This is kind of like that last one we were talking about with the inverse sign, where we factored out the 4 and did that whole thing, right? This is 1 over 4 plus x squared instead of 1 plus x squared. So what do we want to do? We want to take out the 4, which is going to give us 4 times 1 plus x squared over 4. And x squared over 4 we could rewrite as x over 2 squared. And so really what we're looking at here is an integral of, and this 4 can, we can take that 1/4 out if we want, dx over 1 plus x over 2 squared. And then we'll want to make a u substitution in this one, where u is x over 2, and du is 1/2 dx. And I have the 1/2 dx, right? I just have an extra 1/2. So I have to keep a 1/2 outside of here, and the other 1/2 can come in here with the dx and become a du. Everybody good with that? All right, so we end up with natural log absolute value of our first u, which was 4 plus x squared. So natural log absolute value of 4 plus x squared. And then we end up with plus 1/2 the integral of du over 1 plus u squared. Everybody good with that? Technically, I probably should have let's do this. Instead of calling that du and u, let's make a different variable. Let's make those v. Yeah. And then we just integrate that one. So we have natural log absolute value 4 plus x squared plus 1/2, and then this one is just inverse tangent of v, which was x over 2. And then don't forget your plus a constant. Everybody good there? Makes sense, yeah. I don't know, what is that? That's choice D. They got rid of the absolute value on the x squared plus 4 because x squared is positive and 4 is positive. So add them together, it's always positive. All right, 44. We've got an integral of cosine theta e to the sine theta d theta. If I remember correctly, this is the first one of the u substitutions that we did. I could be wrong, but I think it is. What do we want u to be? Yeah, we'll just let u equal sine theta. Du will be cosine theta d theta. So this just becomes an integral of e to the u, and then cosine theta d theta becomes du. So we end up with e to the u plus our constant, or e to the sine theta plus our constant. Any questions on that one? Choice B. Exciting. All right, 23 will be next. An integral of sine theta cosine theta d theta. 2 different ways you can do this one. Actually, 3 different ways you could do this one probably. But the first 2 ways are very similar. It was with just a u substitution. Now, if it were me, I would let u equal, I don't know if this will work out because I haven't looked at the answer choices, but if it were me, I would let u equal sine theta. All right, if u is sine theta, then du will be cosine theta d theta. And to me, that's the easiest way to do this one. This just ends up becoming the integral of u du, or u squared over 2 plus a constant. And so we say that sine squared theta over 2 plus a constant. Is that one of our answer choices? Probably not, huh? Yeah. So we will deal with why that's not one of our answer choices in a second. This is a perfectly 100% correct integral here. Now, another thing we could do, which if I look at the answer choices, oh, this one is one of the answer choices. Okay. No, this one's not. This one's not either. Never mind. But we're going to do it this way anyway. We're going to call this u equal cosine theta, and du then is negative sine theta d theta. So we'll have to put in a negative sign outside and inside. And this would become the opposite of the integral of, don't need to write cosine anymore, the opposite of the integral of u du, which would become u squared over 2 with a negative in front plus your constant, or negative cosine squared theta over 2 plus a constant, which, again, is not one of your answer choices, which we'll deal with that in a second. But this is also a perfectly good and acceptable answer to this problem. Now, the way that they, in this book, would have you solve this one, and I don't think this, I think one of those other two would have been an answer choice on the AP test. I don't think that this way is the way that they would have you do it, but I could be wrong. Sine theta cosine theta is almost 2 sine theta cosine theta. So I would put a 2 and a 1/2 there and call this 1/2 the integral of sine 2 theta d theta using the double angle identity for sum. So this is another way to do this. This time you'll let u equal 2 theta, du will be 2 d theta. You'll put in a 2, you'll put in another 1/2, and you'll end up with 1/4 the integral of sine u du. And the integral of sine is negative cosine, so we'll have negative 1/4 cosine 2 theta plus your constant. And I bet that's an answer choice. That one's an answer choice, choice B. So there's not really a good way of seeing which way to do that problem right off the bat, because if you look at the answer choices, there are a couple answer choices that look very similar to both of those. They just have the negative signs and or don't have the negative signs, right? And then there's some where they've converted it to a double angle and done it that way. So one thing to remember is, and we can show this here, is that cosine 2 theta, right? Remember that cosine 2 theta is equal to 3 different things. One is cosine squared minus sine squared. I'm not going to use that one. But cosine 2 theta is equal to 1 minus 2 sine squared theta. It's also equal to 2 cosine squared theta minus 1. Double angle identities for cosine. It's also equal to cosine squared theta minus sine squared theta, like I said, but we're going to not worry about that one. So I could have said, really, I had negative 1/4 of 1 minus 2 sine squared theta plus our constant, right, which would have been negative 1/4 plus 1/2 sine squared theta plus a constant. And 1/2 sine squared 2 theta, or sorry, 1/2 sine squared theta plus a constant was one of our other answer choices, right? True? We'll note that it's got this extra negative 1/4. That's okay. What is negative 1/4? It's a constant. So if I have 1/2 sine squared theta plus a constant, that's the same as this, effectively. This is still 1/2 sine squared theta plus a constant. Constant's different, but remember the constant could be any value you want it to be, so that's okay. And if you did this with 2 cosine squared theta minus 1, you'd end up getting this with an extra constant thrown into it also. So they're all legitimate answers. They all differ by a constant, but that's life. So, everybody good there? That's a fun one. Other questions? 70. Yeah. Maybe I can. All right. Dx over 1 minus e to the x. All right. So any thoughts on how we might go through that one? What? All right. So if we let u equal e to the x, then du is going to be e to the x dx. That seems like that's going to be a little bit of a problem. Perhaps. Now, this is not a bad idea. This would actually work if you knew some other Calc 2 methods. This would work just fine. You'd end up with 1 minus u here. In fact, actually, yeah, I guess it'd work out the same way. Either way, if you let u equal e to the x, you'd end up with 1 minus u, but you'd have to put an e to the x in the numerator, which if you put an e to the x in the numerator, you'd have to put one in the denominator, which it can't be pulled out, right? So you'd end up with something like this. Which would give you du over u times 1 minus u, right? Which is not an integral that we know how to solve for this class. It is an integral that is fairly easily solved using something called partial fraction decomposition, but that's not for us. So your idea is good. It would work in theory, but it does not work for us in this class. Anybody else have a different idea? Anybody in the Zoom have an idea? Any other way we might be able to try to rewrite this in any sort of way? Nobody?
U equals 1 minus e to the x.
Okay, we can look at that. If u equals 1 minus e to the x, what would du be? Should just be negative e to the x dx, right? What's that going to do for us? Anything? What do? We'd have to do the same kind of thing, right? We have to put in a negative e to the x up there with the dx, which would mean we put a negative in and then an e to the x and a 1 minus e to the x down here still. What's that going to do? What does that turn this all into? Negative integral du over u, and then what's e to the x? E to the x is 1 minus u. So that looks just like that other integral that we had a minute ago, doesn't it? That's a good idea. How would you separate it into two integrals? Somebody here said separate it into two integrals. So I'm saying, how would you separate that into two integrals? It's a good thought. Is it what? You don't know. Other thoughts? Zoom people, other thoughts? Come on, you guys need to think. This is a challenge problem. It's supposed to be challenging. Anybody have a good idea?
You said we need to rewrite it, correct? Like we have to rewrite it somehow?
We're going to have to rewrite it in some way, yeah. That's correct. Oh, this is my gross.
Wait, isn't it just negative ln of the square root of ex or something? Or 1 minus
ln. Isn't it what? Isn't it what? I'm not sure what you're saying.
Isn't it just like negative ln square root? Oh wait, no, ln to absolute value of 1 minus e to the power of x.
I'm not, no.
Oh, okay.
All right, here's what we're gonna try to do. Let's do this. Let us rewrite what's in the numerator. So let's rewrite this as 1 minus e to the x plus e to the x. And this is probably more difficult than something you're going to see on the AP test. Over 1 minus e to the x dx. Would you guys agree that those are still the same thing? Okay. All right. Now, let's rewrite that taking this piece of it as one fraction and this piece of it as another fraction and have two separate integrals, which is what you're saying, right? Two separate integrals? Yeah, I just didn't know how to get there. That's fine. So 1 minus e to the x over 1 minus e to the x ought to be 1. And then we have an integral of e to the x over 1 minus e to the x. And that one we should now be able to do. And the 1 we should also be able to do, right? So the integral of 1 is just, I don't know why I put an x squared, x, right? And then what about the e to the x over 1 minus e to the x? You guys were looking at something like this similar way. We're trying to do a u sub, right? U equals 1 minus e to the x. Du is negative e to the x dx, so negative, negative. We end up with x minus the integral of du over u, or x minus natural log absolute value 1 minus e to the x, plus your constant. Good or no? Wonderful. One of my children called chocolate milk. I'm getting a little bit done with chocolate milk all over. All right. Other questions? $74. Sure. All right, 74. Oh, 75. Yeah, we'll do 75 after we do 74. So 74 says the integral of tangent theta minus 1 squared d theta. Any thoughts on that one? Any thoughts on that one?
Multiply it out.
All right, let's try multiplying it out. That'll give us tangent squared theta minus 2 tangent theta plus 1 d theta. Yeah. All right, do we know how to integrate 2 tangent theta? We integrated tangent theta, right? We did it as a U substitution. I said maybe you want to memorize it, maybe you don't, but like as a U substitution is sine over cosine. And we know how to integrate 1, but we don't know how to integrate tangent squared, right? Is there a way to rewrite tangent squared though? What is tangent squared the same as? Secant squared theta minus 1 using a Pythagorean trig identity, right? 1 plus tangent squared is secant squared. So secant squared minus 1 is tangent squared. So we've really got an integral of secant squared theta minus 1 plus 1. And then minus 2 tangent theta. The plus 1 and the minus 1 obviously go away. And what's the integral of secant squared? Tangent. And then the integral of minus 2 tangent theta. Well, that's minus 2 times the integral of sine theta over cosine theta d theta. And to integrate sine over cosine, we need to let u equal cosine. Du is negative sine. We've got the negative, right, already right here. If we want to, we can put a negative in and then make that a plus. And then all we'll do is say this is now tangent theta plus 2 integrals of du over u, or tangent theta plus 2 natural log absolute value cosine theta, plus your constant, which tangent theta plus 2 natural log absolute theta. It looks like choice B. Yeah. Good. Good. Wonderful. All right. Then 75. 75, we've got d theta, integral of d theta over 1 plus sine theta. Any thoughts on that one? Same as the rewrite thing. It's sort of similar to that. Well, there's a way that we could do it that is sort of similar to that. Not quite exactly the same though. We're going to want to multiply the top and the bottom of this one by something. Any thoughts on what we might want to multiply the top and the bottom by? Not cosine. Oftentimes, if we have trig functions and we want to manipulate them, we need to like rewrite them in terms of other trig functions. And what would I multiply 1 plus sine by to turn it into something that I could then turn into a different trig function?
-1?
No. Because then that's just -1 minus sine theta. That's still just sine theta. What? No, I don't want to multiply it by anything like with, I'm going to multiply it by something with sine in it. This is something that we did with indeterminate limits. What do you sometimes have to multiply by? The conjugate. That is common in trig stuff as well. I'm going to multiply this by 1 minus sine theta and 1 minus sine theta. And that ought to give me now 1 minus sine theta, d theta, over, well, if I distribute all that out, I get 1 minus sine squared theta. And what's good about 1 minus sine squared theta? Yeah, it's just a trig identity. It is cosine squared. So we have 1 minus sine theta over cosine squared theta g theta. And then what do you think we should do? We've done this a few times now. Separate it into two different ones. So 1 over cosine squared theta minus sine theta over cosine squared theta. What's 1 over cosine squared theta? Secant squared theta, d theta. And what about over here? What are our thoughts on this one?
Secant tangent.
Secant tangent, right? And what do we end up with? We end up with the integral of secant squared, which is tangent, and the integral of secant tangent, which is secant plus our constant. Good or no? Looks like that's choice E. Any questions there on that one? All right. Other questions on the multiple choice? You're done, Sarah? No more? No more today. Anybody else? Any other questions on the multiple choice? All right. Oh,
49, please.
49. Oh. How do we know? Sorry, let me ask this. How do we know when to multiply it out and when to use a U sub? Well, you can only use a U sub if it's easy enough to build in the DU. So if it's not easy to build in the DU, you're going to have to do something else with the problem. You know, most of the ones that say challenge in here, I think are more difficult than what you'll end up seeing on the AP test. Would you agree with that? Yeah, me too. So I wouldn't be too worried about some of these like 74 and 75 where you had to distribute stuff out and rewrite a lot. Yeah, but you can't use a U sub unless you can find your DU in there somehow or build the DU in some nice, easy way. All right, 49. Oh, that's a fun looking one. E to the x plus e to the negative x over e to the x minus e to the negative x dx. Okay. Any thoughts on that one? It looks difficult. Do you agree? It looks difficult. It's easy.
Do we separate it?
Nope.
U sub ex e negative x.
Yeah, we're going to do a u sub e to the x minus e to the negative x. What's du? Well, the derivative of e to the x is e to the x. And the derivative of negative e to the negative x ought to be plus e to the negative x, which is exactly what we have in the numerator, right? We end up with du over u, or natural log absolute value u, or natural log absolute value e to the x minus e to the negative x, plus your constant. Good or no? Other questions? Any more from the multiple choice? 71. Yep, we'll do 79 here after we do 71. 71, we've got the integral of 2 minus y squared over 4 root y dy. All right, so for 71, because we just have a singular term in the denominator and everything else in the numerator is a polynomial, is just a, I mean, this is really just a trinomial here if we were to distribute it out. That's exactly what we're going to want to do. We're going to want to distribute that out. So 4 minus 4y plus y squared over 4 root y dy. Okay? And then anytime you have a polynomial, or it doesn't have to be a polynomial, but something that could be differentiated using the power rule or integrated using the power rule, all divided by a single term down here, just divide each term by. So 4 divided by 4 root y should give you, that'd be, the 4's cancel, right? You have 1 over root y, that's y to the negative 1/2. And then 4y over 4 root y, the 4's cancel, and y divided by root y is y to the positive 1/2. And so it's minus y to the 1/2. And then this one becomes plus 1/4. And then y squared over y to the 1/2 should be y to the 3/2. And then you'll just integrate each of those. So that one's 2 root y. This one's minus, that goes up to 3/2, and so it becomes minus 2/3 y to the 3/2. And this one goes up to 5/2, so that becomes a fourth of 2/5. That's 1/10, right? Plus 1/10 y to the 5/2 plus your constant. Does that make sense? Yeah. Everybody good there with 71? Looks like that's what is that? Choice D? Looks like that's choice D. Yeah, everyone good there? That's a good one to take a look at, right? Dividing everything in the numerator by that one term in the denominator. All right. So 79 says find the acceleration needed to bring a particle moving with a velocity of 75 feet per second. We want it to stop in 5 seconds. Any thoughts on how we'll do that one? Anybody? Thoughts on that one?
I feel like we need to somehow write an equation for it.
Okay, that seems good. What kind of equation do we want to write? What kind of equation do we want to write for that? Any thoughts on that? Or no? Nobody? Zoom people?
75 minus something, maybe?
All right, let's try this. Let's go dv dt And our derivative of velocity should be acceleration, shouldn't it? Okay. And what do we know then? If the derivative of velocity is acceleration, that means that what is the function for velocity? Velocity should be a times t plus some constant. So there's an equation. How does that help us?
We know v and t.
Right, we know v, right? And we know that at t equals 0, our velocity is 75. So that should help us find our constant. Okay. So 75 equals 0 plus our constant. So our constant is 75. So we have v equals at plus 75. And we want to know what the acceleration needs to be to make the velocity 0 in 5 seconds, right? So we want the velocity to be 0. We want it to take 5 seconds. What should we get for our value of A? A ought to be just negative 15. Good or no? Other questions? Anybody else in the Zoom? Any more multiple choice questions? All right. So Monday, we will go over the definite integral ones. I think we have time right now to go through this one train problem at least. I think we have enough time to do that, yeah. And then we'll do, oh sure. So we're gonna do this train problem and then we'll be done. Sound good, everybody? Okay. So we are looking first at, we want to find the average acceleration of this train given the velocity, the values of the velocity in the chart. So how are we going to find the average acceleration? From what is it? From 2 to 8. Right? All we should do is just find our v of 8 minus our v of 2 over our 8 minus 2, which looks like, what does that become? Negative 120 minus 100 over 6, which, what is that? Negative 220 over 6, negative 110 over 3. Good? That was worth 1 point. Everybody at home good with that one?
Yeah.
Wonderful. All right. Part B, does the do the data? I feel like that should be does. I don't know. I guess, is the data like one thing? Is this the data? Or is like this data and this data and this? I don't know. Good question. Weird. Okay. I think it could be either one. I think you're right, because the plural of data is data or data, whatever you want to call it. I don't know. Either way. Does it support does all this junk up here in this chart support the conclusion that the velocity of the train is 100 meters per minute at some time between 5 and 8? Okay. And why do you say yes? All right, the function is differentiable, which means that the function is continuous. And if the velocity changes from 40 to negative 120 from 5 to 8, it must have, since it was continuous, gone through negative 100 meters per minute, right? So we would say yes by the intermediate value theorem. You would say that the function is continuous because it is differentiable. And you would say it goes from 40 to negative 120. So it must hit every value between 40 and negative 120, which includes negative 100. And they would give you 2 points for that. So 1 point for noting that negative 100 is between 40 and negative 120, and 1 point for the answer of yes, because of the intermediate value theorem. And it specifically says conclusion using IVT. So if you did not state intermediate value theorem, you would not get the points for that. So if you're using a theorem, make sure you state the theorem. Good? No, neither of them prove that. A function being differentiable means that a function is continuous. Yeah. But the difference between the intermediate value theorem, well, and the mean value theorem, is the intermediate value theorem says this, right? What we just said. It says that if the y values change from a to b, or from f of a to f of b, that every value between there must have been a data point on this graph on the interval between 5 and 8. So any number I pick between 40 and negative 120, I would get that value between 5 and 8. That's the intermediate value theorem. The mean value theorem, supposing we were talking about on the same interval, the mean value theorem would say that the instantaneous rate of change, so that the slope or the derivative between 5 and 8 is equal to the average rate of change. So, you do negative 120 minus 40, get negative 160 over 3. We know that, you would know that the derivative somewhere between 5 and 8 equal negative 160. Does that make sense? Yeah. Good distinction between those two theorems. All right. Part C. We've got at time t equals 2, the train is 300 meters east of the station of Origin Station. They're so clever on the AP test. They've called the station Origin Station. And it's moving to the east, okay? And we want to write an expression involving an integral that gives the position of train A in meters from the origin station at time t equals 12, okay? So we want to start at t equals 2, because that's where we know where it is, right? At t equals 2, it's 300 meters east. And so its position at t equals 12 ought to be its starting location at t equals 2, which was 300, plus the integral from 2 to 12 of, what do they call the function? They call it the v sub a of t dt. So that would give us the position of the train at t equals 12. Initial position plus displacement. And then they want us to use a trapezoidal sum to approximate the position at t equals 12. So using a trapezoidal sum, we will note that the subintervals 2 to 5 is 3, 5 to 8 is 3, 8 to 12 is 4. Not equal subintervals, so you can't just use the formula. Okay? So you got to find each trapezoid separately. So we will do 300 plus our first trapezoid should be 100 plus 40. So 140, right? We'll write it down. 100 plus 40 divided by 2. And then what was the length of that interval? That one was 3, all right? The next one should be 40 minus 120 over 2. Also times 3. And then the last one should be negative 120 minus 150 over 2. And that one was 4 units. And then you just do some fun arithmetic to figure out what that is. So what is this? This is 300 plus, what is that? 140 over 2 is 70. So 70 times 3 is 210. What's that? Negative 80. So negative 40 times 3 is minus 120. That one's what? Negative 270. So that's negative 135, which ought to be negative 540. Does that sound right to everybody? Yeah. So what do we end up with? Negative 150 as our position. And we would say negative 150, or so we might say it's 150 meters west of origin station. Oh boy. Yeah, or you could say it's at a position of negative 150. On the, yeah, it says it's approximately 150 meters west of origin station is what the scoring guide says. So 3 points for that one, 1 for your first expression, 1 point for correctly setting up your trapezoidal sum, and 1 point for remembering the initial condition and getting a final answer of 150 meters west of origin station. Everybody good there? Yeah. Okay. All right, last part, part D, a second train. Train B is traveling north from origin station. How exciting. Okay, so, well, let's see here. We'll go back and read the whole thing. At any time t, the velocity of B is given by its velocity function, and at t equals 2, it's 400 meters north of the station. And we want to find the rate at which the distance between them is changing. So we are looking at, here's origin station. Here is train A. Here is train B. And we're looking for the rate of change between them, which would be this diagonal. So what are we looking at? We're looking at a right triangle here. We're looking at this first train was train A, second train was train B. We knew that at the time we were interested in, A was equal to 300 and B was equal to 400. And to find the rate of change, that's what it said, right? The rate of change of the distance, or was it? Yeah, what time is it? Yeah, okay. So at t equals 2, we would say that a squared plus b squared equals b squared, and 2a dA dt plus 2b dB dt equals 2c dC dt, and then you plug in all your values. So a was 300, so we have 600 times its rate of change at 2. What was its rate of change at 2? 100? And then 2 times b. And then you'd have to figure out what the rate of change of b was. So at 2, what is that going to come out to be? Negative 20 plus 120 is 105. Is that right? Yeah? Did I do that right? 4 negative 20 plus 120. No, 125. Huh. I can do math. And then equals 2 times c. Well, if this was 300 and 400, c is going to be 500. And then we have our dC dt. So you just solve for dC dt. This becomes what? I don't know what this all multiplies out to. According to the scoring guide, that all comes out to be 160 meters per minute if you solve that. Does that make sense to everybody for the train problem? That was worth
Yeah.
3 points. 2 points for correctly getting this, and then 1 for the final answer. And so we will do tomorrow, we will do numbers 8 and 9. And then we'll probably do one more in class, just to do one more in class. And then we'll have the quiz on it on Friday. Everybody good? All right. Zoom, goodbye. If you have questions, stay. People here. Goodbye.
Thank you.
If you have questions, stay. You're welcome.